Okay, this is a really crazy function called the greatest integer function. It's defined by these weird double brackets around the variable x. It's equal to the greatest integer that is less than or equal to x. And to graph it, we're going to make a table of x's and y's. And by the way, I have these weird brackets going on the page before I even discuss what's going on. And that's because I forgot to put double brackets. These are double brackets around the variable x. When x is equal to 4, y is equal to the greatest integer that's less than or equal to 4, which is 4 itself. When x is equal to anything all the way up to 4.999999, y is going to still be equal to 4. Okay, so what happens when we get to a number just slightly smaller than 4? 3.9? Well, the greatest integer that's less than or equal to 3.9 is 3. And that happens all the way down to x equals 3. All right, that's why it also has y equals 3. But then when we skip down to the 2's, 2.9, now the greatest integer less than or equal to x is equal to 2. So you see there's a pattern going on here, and we're going to graph this on the x and y axis, and we're going to get these steps like a stair step going up and down on the graph. So if you consider what happens when x is equal to 0, when x is equal to 0, the greatest integer that's less than or equal to 0 is 0 itself. So we have a solid point at 0. And for every value up to 0.9999, we will have y equals 0. But then exactly at 1, we get an open circle. Open circle because what is the greatest integer of 1? Actually 1. It's 1 itself, so it jumps up to 1 with a solid circle, then a step all the way until we get to 2, where we get a round open circle, and we jump up to the next integer, 2, and then we move to the right until we get to 3, round open circle, then jump up to 4, 3, and 4, and 5. So, and you do it also in the negative direction. So if you actually graph these points, you see that you're getting these jumps in the function. Okay, so this is y equals the greatest integer of x. So what we're going to do here is show that the limit as x approaches 3 of the greatest integer x does not exist. Okay, the solution. Well, since the greatest integer of x equals 3, when 3 is less than x, is less than or equal to x, is less than 4, that implies a limit as x approaches 3 from the positive side of the greatest integer of x is actually equal to 3. Similarly, since the greatest integer of x being equal to 2 happens when 2 is less than or equal to x is less than 3, that implies a limit as x approaches 3 from the negative side of this greatest integer of x is equal to 2. And at this point, we can see that the limit as x approaches 3 from the positive side is not equal to the limit as x approaches 3 from the negative side. See, one is equal to 3 while the other is equal to 2, and that means that the limit itself is not going to exist.